So we are going to continue looking at how to factor trinomials in this video. The difference now is going to be that this lead coefficient is not 1. And so that's a problem. The methodology that we talked about where we're looking for that m and n, it doesn't work right off the bat because now we have another number that is involved. There are lots and lots of different methods for factoring trinomials. If the method I'm about to show you does not work for you and you already have a method, feel free to use that one. There are methods that you can look up online. I like this method because it boils things down to the same type of problem every time. This is called MFDRB. Let me show it to you and say it again. MFDRB. My father drinks Red Bull. Now, that's not what it actually stands for when we go to use it, but that's the way a lot of people remember it. Right? My father drinks Red Bull. MFDRB. What that actually stands for mathematically is multiply, factor, divide, reduce, and then bottoms up. Let's talk about what that means in terms of a problem. Now, because right now I understand those are basically just words. My father drinks Red Bull, multiply, factor, divide, reduce, bottoms up. So here's what we mean by each one of those. Let's do an example. So we have 2x squared plus 19x plus 9. The number out in front is not a 1. So we have to do some method to work with this. So as we said in that math, in the my father drinks Red Bull, in the alliteration, M is for multiply, right? In the multiply step, yes, I did just pause out for a second. You can laugh at me if you need to. All right, so in my multiply step, I'm going to take my front number and I'm going to multiply it by my back number. So 2 times 9 gives me 18. And when I do that, I'm just going to move that entire 18 to the back. So that's going to be x squared plus 19x plus 18. That's my multiply step. Next, I factor. See, now my factoring step, and one of the reasons I like this methodology is that the factoring step is always just factoring a trinomial that leads with a 1. So it's just like the factoring problems that we were working on in our previous examples. So factor, two numbers that when I multiply them together I get 18, and when I add them I get 19. That's going to give me x plus 1 and x plus 18. Next I have my D, that is divide. Remember that number I brought back, right? It was a 2. So now I'm going to divide that on both of these back numbers. So my x plus 1 becomes x plus 1 over 2. My x plus 18 becomes x plus 18 over 2. Next, I want to reduce. So x plus 1/2, that does not reduce. 1/2 does not reduce, so it remains x plus 1/2. And then I've got x plus 18 over 2, and that 18 over 2 will reduce to just plain old 9. X plus 9. And then my last step is bottoms up. Anything that is left in the denominator, so like this 2 right here, gets shifted up into the numerator. So that becomes 2x plus 1. And since this doesn't have anything to pull up, it just remains x plus 9. So this factors to 2x plus 1 times x . So let's try this again. There may have been a big pause there, I'm not sure. So we've got 8x squared minus 10x minus 7. And again, we're going to do that M, F, D, R, B. So I take my front number, 8, and multiply it by the negative 7. That's my multiply step. 8 times negative 7, so that gives me x squared minus 10x minus 7. Oops, not minus 7. Minus 7 times 8, my bad, which is 56. Now, I know that my factors are going, when I factor, they have two different signs. So I'm going to try and factor that 56. That's going to be x minus something and x plus something. So two numbers, when I multiply them together, I get 56, but when I add them, I get negative 10. What are those two numbers? I can break 56 down into as many different ways as I want. 7, 8, 14, 4, 28, 2, 56, 1. Remember, 1 is positive, 1 is negative. Looking for a difference of 10, I get that 14 and the 4. Since the 10 is negative, I'm going to make the 14 negative. All right, since the 10 is negative, the 14 is negative. So I have x minus 14 and x plus 4. Now I divide. So remember, my original number was 8. So I take each of those, x minus 14 over 8, x plus 4 over 8, reduce x minus 7/4, x plus 1/2, and bottoms up. 4x minus 7, 2x plus 1. So there's my factoring. So domain. Remember, these are the values that can be plugged in, right? Domain is the set of all input values. All right? It's the x's, right? Usually x. So when we talk about domain, it's going to ask you questions about whether or not you can plug certain values in. What is the domain of the function? Are you allowed to put in negative numbers? For right now, there's only two domain restrictions that we're going to have to worry about. All right? If there is a variable in the denominator, the denominator cannot equal 0. Ever, 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 ever. All right? So the denominator is never allowed to be 0. So if I have like 1 over x, whatever's in the bottom cannot equal 0. If I had 1 over x plus 4, whatever is in the bottom cannot equal 0. And so that would mean that x cannot equal negative 4. So the denominator is not allowed to be 0. The second thing with domain is even roots. And for right now, all we're dealing with are square roots, right? Even roots must be non-negative. So if you take the square root of something, whatever you have inside the square root has got to be greater than or equal to 0. But it can equal 0. You are allowed to have a 0 under a square root. That should get you through all of the problems that you have on this skills support for functions. So if you have any other questions, anything that you would like to talk about, any specific topics that you feel that we go over in class that you feel you'd like expanded upon, please let me know. Have a great evening or day, depending on what time you're watching this.